Hi, everyone. Very appreciate the opportunity to come here. A little bit background on me. It's I right now work for Coinbase, and but I used to work for Google. So I joined Google in 2007, then left in 2015. So I was there when Bazel was created. After leaving Google, I keep trying to convince everybody else, oh, Bazel is awesome. We should use them everywhere we go. Yeah, so I'm very happy that Coinbase use Bazel a lot, actually, internally. So I was hoping today I will talk about a little bit about how we, the experiences we use them, and maybe share something that can save everybody a couple hours pulling their hair out when dealing with problems. Yeah, so Coinbase actually, we use a monorepo model that basically have a lot of different language, like a project in different languages combined together. And what's more important is, the reason Bazel works for us is we work in mostly full stack mode, right? Like you have microservices. Every time you do build, maybe you need to launch like a couple containers just in order to do like implement all the features. So it's Bazel works for that. But there's also ups and downs, right? Like love and hate. So I was thinking about like maybe three issues that when there was a call paper, I was thinking about talking about three issues. So the first one I thought about is RuleSCO and the Rule Stalker that was giving us a lot of trouble, but it's mostly self-inflicted, like due to the way we used RuleSCO, Rule Stalker very early, and there was a lot of craft accumulated over the years. It's not very standard. Then I thought about talking about RDEPs. So like if you want to do any useful thing with Bazel query, like you end up with running RDEPs, and the RDEPs require you to actually download all your external dependencies together before it even runs. So it's very painful to use. But then that one is also a known issue for a long time. So today I was going to talk about this. There's another thing that bugs us a lot. Yeah, it's about external repositories. So, like outside Google, everybody use all different libraries, and most of the time you want to upgrade one, right? So there's like multiple places you can put in to change the version you want to use. But surprisingly, sometimes it doesn't take effect. We just kind of hope it works, right? So on the paper, in Bazel, there's only one place you can specify a version of repositories, which is in the workspace file. And but in reality, the workspace file is nobody writes like we use macros all over the place. You use like a multiple load statement inside the workspace file, so it's very hard to trace where that external dependency actually come from. And then you also have the issue where they override each other, and you would assume they override, but sometimes they don't, right? So then, if you run into this kind of problem after enough searching and pulling it out, you end up on this bug, which opens in 2021, and hasn't been solved yet, and there's no solution for it, but there's workaround. So today we're gonna talk a little bit in detail on that, right? So the expectation would be, if we define something in workspace, it should expect it to work as the way that a normal programming language works. But then I put some code over there that we're gonna work through a little bit, right? So I create this test workspace that basically define two repositories. Like normally you wouldn't do this anyway, right? So but it could be like you're loading an external dependency, which also loads its own dependencies, and you end up with something like this. You have like basically two same dependencies, but specified twice with different versions. So you want to assume that after this workspace got loaded, you would end up with the one that defined the last, right? So it's Python, right? Like you expect it to execute from top to bottom. But then you basically do a sort of I put something in the build.bazel file, and then you have an output. And basically, if you specifically load this dependency and basically do a print, you get the expected behavior, which is 1.0.3. So far so good, right? So now enter the second test, which notice that what's changed in the middle is basically you have a load statement that put you inside the two HTTP archive repositories. By the way, it doesn't necessarily with HTTP archive, it works with any repository rule. So now you do the same build query, you build this same build.bazel file, and now what happens? Your dependency got reverted to like 1.0.2. Right, so this, I can swear this really occurs, and I actually did multiple tests about this. And the question is why, and how you deal with this. And this is the source of the problem where you modify, version specify in one file, and then it's supposed to take effect, but doesn't really, right? So the truth here is basically Bazel load workspace is in trunks, essentially. Like it's just a way how Bazel internally works. Basically, it's separated by the array load statement. So within each trunk, or that's actually not the term that Bazel actually internally use, it's actually within each trunk it actually overrides as you expect, but across the trunks it doesn't really override. So whatever it appears before the load statement, it's solidified or like it's set in stone. You can't change it later. And the other thing doesn't work here is like if you try to use existing rules, which is a function that you can use to have like introspection on your workspace file, it doesn't really give you the right result. So yeah, so now to verify that, I did something with I wrote like a depths.bazel file, right? Depths.bazel file just have one thing, basically return native existing rules to workspace, and then you put this dump function that at the bottom of the workspace, and hopefully it will give you correct result. But it turns out it doesn't, right? So whatever you get from the parsing or executing of the workspace file doesn't really match what you actually get from building the actual targets. Okay, so armed with this knowledge, well, I mean, I hope this will save somebody a couple hours to trying to figure this out. But at the end of the day, you will see this issue come up again and again, like everybody new to Bazel, and they couldn't figure out, oh, how do we get around this kind of issue? So basically, there's a couple workarounds, right? One is you can refactor your workspace file that basically put all the load statements to the top, which usually you want to do that, but I mean, there's reasons you can't, right? Like you may be loading a file that has to be declared by, there's multiple reasons for that. But then you also have, so if you can't do that, then you have to use this insurance pattern. That basically, I think if you watch for like RuleScope, I mean, popular rules, they all already does that with maybe with ensure. But what you really want to do is that you want to check whether there's actually existing dependencies already specified. And if it's there, because there's no way for you to know whether you can actually override that effectively, so the best thing, the only thing to do there is basically just fail, essentially, to ask for the author to evaluate whether you want to continue to override or you basically fail, right? Like I think that's the only thing. So basically, we discovered this issue in our code space. Then obviously I couldn't put a fail directly to block everybody. So I put a print. So now, I mean, every time somebody does like Bazel, I passive aggressively my rule print out like hundreds of warning messages saying, oh, you want this version, but you're not getting it because you just can't. Yeah. So, well, I mean, the workspace, you can also just, the way I found it work for us is basically you specify all you override early as possible, right? So instead of overriding from bottom to top, you actually have this pattern of overriding to top to bottom. Like you just, as early as possible, you say, this is the version I want to override, and then have all the other dependencies use this insurance pattern, basically ignore or warning, so that you can actually get the version you actually needed. Yeah. So yeah, well, I mean, with this knowledge, you can also sort of simulate this behavior. inside the workspace. So basically, you have this rule basically does this merge thing that basically detect whether there's existing rules, and if there is, basically get rid of from the result. But then the downside is obviously you have to record existing rules, value of existing rules after every load statement. So it's very painful to do, but at least you will get the correct result. Yeah, so basically, yeah, you see like you need to specify like R1, R2, R3 all the way, like basically, and then merge at the bottom. Cool, yeah, so after all that, I mean, the happy ending for this story is like I finally, during this process, I also discovered, oh, Bazel has this JSON encode thing that I can output all the Python directories or Starlock directories into JSON that I can use to sort of do all sorts of post analysis. So I just I wrote this thing to basically output every dependencies in the JSON, and then you can query and see, yeah, you can finally get the correct result. Yeah, I think that's my talk. I was hoping, to share this to save somebody a few hours. Thank you.